Welcome to my channel Living Linux. In this video I want to have a quick look at Bianbu 2.1. I'm going to skip my usual test because I didn't see much of a difference with the earlier release of Bianbu. But you can see that I'm running it on my Banana Pi F3 with the RISC-V spacemit K1, and well, it seems that you do have some access to the PowerVR GPU. So when I first looked at the release notes, well, unless I'm going crazy, but it mentioned that it has Ollama in the repository and that it has OpenCL support. So I'm not really sure why they changed the release notes. For OpenCL, I can understand that they might think it's better not to mention it, because at the moment I could not get any decent performance with OpenCL. So perhaps I did something with this setup wrong, I don't know, but so far I got some disappointing results. But at least for Ollama, well, that seems to be working, so I'm not really sure why they changed the release notes. Anyway, I'm going to push Ollama to the end of the video because of memory constraints. So here is a program to do a benchmark of OpenCL. You don't need to build it yourself, you can just do sudo apt install clpeak. And here you can see that they have a sample benchmark, NVIDIA CUDA in a Tesla system. And then, for instance, the memory bandwidth, it's like 700, 800 something. Not really sure if that's gigabytes per second or gigabits per second, but it's all relative. So when I ran clpeak myself, you can see that the memory bandwidth is like very low, and I also assume that it impacts the compute, because if you can't feed enough data to the GPU, then yeah, your benchmark is going to be very low. So there was very little activity on the CPU, so I assume that it was running on the GPU. But since the memory bandwidth is very low, yeah, can't really say for sure. I also tried to run Mandelbolber 2 with OpenCL, but that just crashed. Again, perhaps I need to do something different with the setup of OpenCL. But yeah, so far, not really positive results. Now, I also want to show you that I was able to build Llama.cpp on RISC-V. And yeah, just to be sure, I installed GCC 14 and G++ 14 because that has better support for vector instructions. And then it's quite easy to build Llama.cpp. Just copy these 4 lines and you should be able to build it. And perhaps you want to have like 2, 3, or 4 jobs in parallel. Perhaps also depending on the amount of memory that you have available. So I did a benchmark, and yeah, it's not very fast, but at least when you have vector instructions, it's a lot better than when you only have scalar instructions. And I think it only makes sense to run a large language model when you have at least vector support, and preferably support through an NPU or GPU. So let's see when we have so I used this model, DeepSeek R1 distilled Quen, 1.5 billion parameter file, and yeah, it needs to be converted for Llama.cpp, and it's quite often that they use the extension gguf for that, to indicate that it has been converted. Oh, no. So here I have the command. What is the meaning of life? Well, I would say that the speed for a limited RISC-V system is acceptable. Well, of course, you can argue that it's only a 1.5 billion parameter file. And yeah, I would also advise against going above 1.5 or 2 billion parameter file. So it's getting towards the end of the answer. So just Control C, and then you can see that it is not even 2 tokens per second. Now the last test that I'm going to do is Ollama, and you can install Ollama install like this, spacemit-ollama-toolkit. I also had to reboot to make everything work, and from there I tried the Stable LM2 model, and I thought this is an interesting one because it's only 1.6 billion parameters, but it does have support for multiple languages, including Dutch. And the first time you run this, then it needs to download the model itself. So I already executed this command before, so I have the model already available. Okay, so let's just close the browser so we have as much memory available as possible. Because yeah, that's that. Here we have the system monitor. So it has support for multiple languages, and when you give it enough context, it will recognize the language. And yeah, with those smaller model files, then you will see some more mistakes. Oh. Says doesn't feel so good, and he's not really in the mood for a reaction. So the response is, sorry, I can't answer to hallo en gaat het met jou? And the way the sentences are built up, it's not really how a Dutch person would build up the sentences. So this is not really how you spell this in Dutch. But yeah, it does respond in different ways. So you don't get the same answer over and over again. So it's looks like it's roughly the same speed as Llama.cpp. And you can see that it's running fully on the CPU, and it does have an MPU, but perhaps they don't have access to the driver yet. And of course in the future hopefully we can run it on the MPU, and that we can also do some benchmarks between the MPU and the CPU. And perhaps even better, that hopefully soon we also get the Vulkan driver, and it's also possible to run Llama.cpp through Vulkan, so that we have three options: running it with vectors on the CPU, running it on the MPU, or running it with, for instance, Vulkan on the GPU. So these are all the things that I'm going to show you about Bianbu 2.1, skipping my usual tests like WebGL, Aquarium, and YouTube, because I didn't see any significant difference there. So this is all for now, and I hope to see you again in my next video.